This is 15 Minutes of Impact from the United States Energy Association Power Sector Podcast, sponsored by the Natural Gas Supply Association. I'm Herman K. Trabish. I've covered the power sector since 2006, and I currently report for Utility Dive. In this episode of the podcast series on natural gas issues, we're going to talk with Richard Meyer, Vice President of Energy Markets Analysis and Standards with the American Gas Association. Richard was a key contributor to the just released analysis, The Renewable Natural Gas Advantage. He's going to describe what renewable natural gas is and what its advantages. Richard's worked for over 15 years in energy and policy analysis with the American Gas Association, a leading industry advocacy group, and he stepped into his current executive position in March 2021. Before joining AGA, he worked with global business consultant ICF International. Richard, we'll get to the new report in a minute, but let's begin at the beginning. What is renewable natural gas, RNG? What kinds of biomass produce it? How available are those sources? How does biomass become RNG? And what is renewable natural gas used for?
Herman, thank you for having me. Glad to be here. Let's talk about RNG, renewable natural gas. It's like natural gas, but it's from different types of sources. It's specifically from biogenic or other zero carbon or renewable sources. And what you do is you take this biogenic material, often starts as like a raw biogas that can come from landfills, wastewater treatment plants, different types of agriculture. And that can be processed. That gas can be processed, upgraded, and then turned into what we call pipeline quality, which means it can be put into our existing natural gas infrastructure, our pipelines, our storage systems, and it can be distributed to customers. And those consumers can use that renewable natural gas in the same way they use natural gas today for heating, for manufacturing, for transportation, and in some cases for power generation. So it is
no drilling. You're saying that there's no drilling to get at renewable natural gas. Is that what you're saying?
not in this case. It's not geologic gas, but it's methane. It's the same chemical composition, but it's from renewable sources. And so we can, and really, I'll be technical for a second. We define it as a pipeline compatible gas that has a lower life cycle carbon dioxide equivalent emissions than geologic gas. So in other words, it's the same thing, but it lowers your overall greenhouse gas emissions. And in some cases can be zero or negative depending on the source, but we can unpack that in a minute.
Yeah, I want to get to that. That's the next topic, but uh, you said it comes from it comes from all kinds of sources. You mentioned agricultural sources. I happen to know quite well that it comes from poop. Is that right? I mean, and other kinds of waste materials, but it also comes from like um, waste materials, like landfill waste. Sometimes can produce biogas, renewable natural gas. Can you just tell not the chemistry? My listeners, I don't think are going to want to know the specific chemistry, but just generally, how do those different sources make the same thing is what I'm trying to ask.
It's a good to think about it in two kind of buckets. One is your feedstock. So what is the kind of primary source of your biogas or renewable natural gas? And then what are the processes to go from that primary source to a pipeline compatible fuel? So when you're talking, what you were just talking about are those primary feedstocks. And so that can be the landfills, animal manure, wastewater sludge from our water resource recovery facilities, food waste, agricultural residues, but also sources like forestry and wood product residues, even purpose-grown grasses, for example, or the biogenic fraction of municipal solid waste. Again, sometimes not pretty stuff, but important, waste streams or other sources that can be repurposed recalibrated, upgraded for a usable energy product that not only lowers emissions, but closes a waste stream, right? And so this we're talking about sustainability and good practice on many different levels.
And that's any of that stuff, any of those different kinds of sources, they go into some sort of a closed container. And so that as they decay, the gases that naturally rise up, whether they're in a container or not, can be captured and then as a gas, just like any other method. Is that pretty much it? I mean, there's a lot more technical stuff to it, but is that the basic stuff?
Right. So we just talked feedstocks. Now we're talking the processes, right? And what
Mhm.
you're referring to is the primary way we make renewable natural gas today. And the technical term for this is anaerobic digestion. And simply put, what you do is you take some of that waste and you put it into an oxygen-less environment with microbes, and it converts that biogenic material to renewable gases. And then we can take that raw biogas and upgrade it with some additional equipment and turn it into a pipeline quality renewable natural gas. That said, there's other ways to make renewable natural gas, thermal gasification. Here, kind of think about a really hot controlled fire type system that turns dry biomass into a synthetic gas, which you can then take raw methane or even hydrogen out of that and convert it into a methane product as well. So it's a different process, but again, starting with a biogenic feedstock and turning that into a renewable natural gas.
And that also has to be in some form of closed container. So it goes into this container. I don't mean to hammer at that, but I just want to get a picture of how all this works. It can be in a closed container where it naturally turns to gas, or it can be in a closed container where processes are exercised to turn it into gas. Is that right?
Yeah, not being an engineer, I probably couldn't get into all the niceties of that, but that's pretty much right. You're taking, say, animal manure, you're taking this other waste and putting it into a container, a controlled environment that then decomposes these biogenic sources, and the result of that decomposition process, again, in a controlled environment without oxygen, with the help of our little microbe friends here, will turn that waste into renewable natural gas.
So let's talk about this idea of carbon neutral, and let's talk about why renewable natural gas is considered a carbon neutral resource that can help turn back the climate crisis. Because anything that decays uh, typically puts off this gases that, if they're not captured and used, what happens to them? They go into the environment, they go into the atmosphere, right?
Well, that's right. And so when you use RNG, if like a lot of natural gas, you might combust it. So you're using it in a furnace, you're combusting it in an engine. That process turns that renewable methane into CO2 and some water. That carbon dioxide, however, the carbon portion of that carbon dioxide came from a biogenic source, which meant it already got pulled out of the atmosphere from a biogenic process. So when you kind of do the chemistry and look at the life cycle, if you will, that's a closed loop. You're not adding any more CO2 than you were already extracting from the atmosphere at the beginning of that process. So it's a carbon neutral process when you're just looking at that combustion of RNG. That said, you can also look at the processes upstream and extend our kind of horizon about where we're looking at and counting emissions. And it gets a little technical, but this is what we would call life cycle emissions accounting. And this is really important because in some cases, you're capturing methane, unavoidable methane, say from animal manure at a dairy farm, that methane would have otherwise been released. And so now you get to take credit for that methane that's reduced and the greenhouse gas emission, components that are now avoided from that unavoidable methane. You're taking that methane that's reduced, and you are, using it in that kind of carbon neutral combustion cycle. And the whole thing can be overall carbon negative. And this is the real power of RNG, because now you've got a carbon negative fuel source, which means I can blend a certain volume of RNG into my natural gas stream and get outsized emissions results. I can get, if I blend 20%, I can get more than 20% emissions reductions. So this is where RNG can be a force multiplier for emissions reductions.
What do you mean carbon negative? I get carbon neutral, anything that is let off into the atmosphere is made from the planet, so it's a sort of a cycle, a neutral cycle. But what do you mean carbon negative?
Well, so in other words, you were going to have methane that was contributing to, biogenic methane from, say, this dairy manure, or manure at a dairy farm, and that was going to go into the atmosphere anyway. So that would have created a positive contribution towards emissions. Now we get to capture that, reduce it, and now we get to flip the sign on that. That's now negative. I've removed what would have otherwise been a contributor to the atmosphere, and so I get credit for that reduction before I even use that methane. So now we're okay. We've reduced those emissions, and now I'm going to take that methane and I'm going to process it, and I'm going to put it into our pipeline system, and I'm going to use it in my furnace to keep my home warm during the winter. And that whole process, depending on the source of RNG and the process and some other factors, can be carbon negative. It could be a little slightly positive too. So really, you have to do a careful job accounting for all the emissions, all the energy used in processing this fuel source, and then delivering it. And when you add it all up, you can get what we call a carbon intensity score that might be positive, might be a little negative. And there's a lot of good science behind that. That's very policy relevant, because that's how some states credit renewable natural gas for the emissions reductions that it provides.
This episode is brought to you by the Natural Gas Supply Association, a DC-based trade association that represents domestic producers and marketers of natural gas. Natural gas stands out as a fuel of choice for America's energy future. It is affordable, reliable, and sustainable. Today, natural gas powers a growing share of industrial facilities, data centers, homes, and also supports the expansion of renewable energy. The benefits of natural gas rely not only on expanding our nation's energy infrastructure, like pipelines and storage facilities, but also ensuring regulatory certainty so businesses can construct and maintain this infrastructure. The Natural Gas Supply Association advocates for permitting reform to streamline the process for approving necessary infrastructure projects without compromising environmental protections. The natural gas sector has proven itself adaptable and resilient, meeting rising demand while maintaining affordability. By investing in infrastructure, embracing permitting reform, and fostering a fact-based regulatory environment, we can ensure that natural gas continues to be a reliable foundation for America's energy future. It is our responsibility to strengthen this foundation today so that we can meet the energy demands of tomorrow. Learn more by visiting www.ngsa.org.
I think, if I'm not mistaken, if you take the CH4, the methane, which is what is naturally produced by this waste, you use it, you get CO2. Now, methane is a much more destructive greenhouse gas than CO2, so there's benefit in that also, isn't there?
Technically, it has a higher global warming potential, and that global warming potential is defined along the time horizon that you care about. If you're looking at 100 years, it has a certain impact relative to CO2. If you're looking at a shorter time frame, it actually has a larger impact compared to CO2. So if you're in this case, if you're using, again, this is a little technical, but let's say you use that 100-year time horizon, and I've reduced methane that would have been otherwise unavoidable. you get a little over 20 times the credit than you would if you reduce the same amount of CO2. So that's why you get a carbon negative score, because you get a lot of credit for reducing that methane. And then you can use that methane, as I said, in those end use applications, get useful energy out of it, heat my home, maybe get myself, to work, and also reduce emissions in the meantime.
Well, I wanted to ask you during this conversation, I had a note to ask you about pipelines, but you've already told us that it's essentially pipeline. It can use the same pipelines that we have, the same pipeline infrastructure that already exists for fossil-based natural gas. Are there any other infrastructure issues that would limit the use of renewable natural gas? For instance, green hydrogen, it doesn't use the same pipelines as natural gas. And so there's a question about how it could be a viable energy source or molecule source, because it would need a whole set of new infrastructure issues to be addressed. What about with natural gas, renewable natural gas? Does it have specific infrastructure issues?
It's a great question. Let's break this part up. I'm gonna start with like my situation. I live in Washington, D.C. Okay, we've got a house, and let's say my utilities offered me the option to buy renewable natural gas as an add-on, right? Well, that maybe changes a little bit in terms of the cost of my bill, and we can talk about cost in a second, but RNG does cost a little bit more than traditional geologic natural gas. But it doesn't require any other changes. I can use the same furnace, the same piping in my house, the same service line that extends from the street, connected to the same main line, which is connected to the other gas infrastructure. All of that remains unchanged. So we're getting to leverage all of the existing infrastructure without, but I'm getting now this renewable gas product.
That's a
Now,
huge cost advantage.
Well, and it doesn't require me to replace any equipment in my house. And so that makes it a very potentially very cost-effective emissions reduction tool, because I don't have to replace my furnace and put in a new type of heating device. I don't have to, require electrical grid upgrades or anything like that to accommodate my new appliances. So it really can be very minimize the disruption to consumers, which is a real positive advantage here. Now, if you're talking upstream, if you've got a dairy farm that wants to start producing renewable natural gas, they might need some new infrastructure there. They might need a pipeline that extends to the farm. You might need some processing equipment, other equipment to capture this biogenic waste and convert it. So there's some upfront capital expense and then some ongoing expense to keep that process in these machines running. And we can quantify all of that. So there's some upstream infrastructure required, but past that, it can, once you connect into the existing natural gas system, you can leverage what's already there.
The other thing about the upstream, now upstream is where it's produced, downstream is where it's used, just for our listeners'
That's right.
value. But the other thing is that upstream, if you have to pay for some infrastructure, you're also creating a revenue stream that you didn't have before. All this was just going to waste. I live on a horse ranch. All that horse manure it gets put in the trash bin. There's no revenue from it. But if you have a big dairy farm and you go to the expense of putting in the equipment that you need to turn it into natural gas and a pipeline to deliver it wherever it can be used, now you're being able to sell natural gas. You're in the oil business, fossil fuel business, right?
Well, you're now in the renewable natural gas business, and that's exactly right. And we're seeing a lot more activity here. And I'll give you some numbers today. We've gone from about 31 renewable natural gas facilities in 2012 to over 500 today. And it's almost 1,000 facilities once you count those that are planned or under construction. This is a growing market. And that, so these farms, these landfills, they're seeing value that's uncaptured. That we were leaving money on the table before, folks. Now we can create this additional infrastructure, hook into our system, into our natural gas system, and create value from this waste that would have led in many cases to unavoidable emissions that we wanted to reduce already. So it's a win-win-win.
Yeah. So this is the last question I want to ask you, Richard. We're running a little bit short on time, but your paper, The Renewable Natural Gas Advantage, goes a lot into scale, what the potential scale is, whether it's cost competitive, et cetera. Basically, what I'm trying to get at is how significant a role can RNG play in the U.S. energy mix in the near term and in the longer term?
So the paper you're talking about was developed by the American Gas Foundation. This is an independent charitable organization that conducts research that helps inform public policy. And one of the probably more important studies it's done over the past few years, and in 2019, it released a study of renewable natural gas resources. And a lot of folks found that very beneficial to help inform project development, help inform policy, and so forth. And the American Gas Foundation last year said, you know what, we've got to pull that study off the shelf and update it. We've got new data, policy has progressed, technology's getting better. Let's see what more, what's changed over the last few years as all of these technologies and data sets are getting more advanced. What they found is that the technical resource potential, so just before you get into the economics, what could possibly be produced has increased 17% since the prior study. So the size of the pie is getting bigger. Now, the study also did several scenarios and looked at, well, what could we realistically produce and what are the economics associated with that? In other words, once you look at the production costs, how much does it take to get renewable natural gas from that farm into the pipeline system? And what it found, there's different scenarios and the study goes into all the detail, but about 75% of this renewable natural gas can be produced at an average price of $20 or less. There was one very high scenario, what we call our ambitious scenario, that was $23 or less. So around $20 for 75% of this resource. Now, how much resource are we talking about? Well, again, there's kind of different assumptions. How much of this total technical resource base do we plan on utilizing? And in some cases, we have a low utilization. And in our ambitious case, we have a lot higher utilization. And, we're talking somewhere in the ambitious case around 7 quads of energy. Now, that's a quadrillion BTU, which probably doesn't mean much to many people, but the US uses on average, about 95 to 100 every year. I should probably have that handy, but just to give you a sense of scale here. So that seems pretty small, but 7 quadrillion BTU, that is about 3 times the gross energy content of all wind and solar generated today. Now, I'm kind of comparing apples and oranges because we're talking about a potential RNG number in 2050 versus kind of what we're producing today. It's on the scale of the natural gas market today. Our high case is just around the size of what we're consuming in the residential natural gas market. So again, don't look at this as being able to replace or not replace our existing gas molecules. Look at RNG as a component of our energy supply and a key tool to reduce emissions across our economy. That's really where we see the potential here. There's economic potential. Again, these farms, these other groups not leaving money on the table and being able to add cash flow to their operations. And you've got consumers looking to reduce their emissions and having another fuel source that's renewable, that can produce outsized emissions reductions and contribute to overall greenhouse gas emissions reduction goals while leveraging existing infrastructure. So this is an abundant resource, and
Yeah.
we should. There's a chance to use a lot more of this in the future.
There's a real quick, Richard, before we close out, you mentioned it was $20, $23. What is that per megawatt hour, per ton, per billion BTUs? What does that
Per million BTU. So typically natural gas is priced per million BTUs, maybe per MCF, which is almost 1-to-1 there. So yeah, that's per MMBTU. So the commodity price of natural gas today is around $3 or $4, $20. That would be a premium. But that again, the comparison isn't between, say, renewable natural gas and geologic gas. The comparison is renewable natural gas versus other pathways to reduce emissions. And that might be, changes to your electric grid, changes to the equipment in your house, upgrades at your manufacturing facility. What is it going to take to reduce emissions, and how does that compare to using RNG for the equivalent emissions reductions? That's the right cost comparison. And we've done some other work to show that RNG actually is quite competitive on a dollar per ton basis, and could be a real solution for consumers to reduce their emissions footprint.
Okay, we're going to have to leave it there, Richard. Two quick points that I'm going to make. We always talk here on the podcast about an all of the above strategy, and that couldn't be more important right now because we're all looking at this enormous demand growth. And so wherever we can get our resources to produce for us, it could be very vital. And we live in a marvelous age where there's so many potential resources, so many scientific breakthroughs that could produce answers for us and solve our problems, reliability, clean energy. And the other thing I want to mention that you didn't is that a lot of this renewable natural gas can come from places where maybe solar or wind isn't a practical option, or natural gas isn't a practical option. So those are also things we want to consider. But that's all we've got time for, Richard. So I'm going to cut you off there. I want to thank you. American Gas Association Vice President of Energy Markets Analysis and Standards, Richard Meyer, has been detailing for us the key findings and the key factors about renewable natural gas that come up in his just released report, the Renewable Natural Gas Advantage. I also want to thank our sponsor, the Natural Gas Supply Association. And as always, I want to thank our listeners for taking the time to check out the USEA Power Sector Podcast. Don't forget to subscribe, like, and share with everybody you know our quest for energy transition solutions.